Assalamualaikum warahmatullahi wabarakatuh. So today we would like to present to you about Gingko biloba. Gingko biloba is a precious tree that is commonly cultivated as a multi-purpose plant for humane in China. It has been recognized as not only a nutritional and functional material resource, but also a medicinal plant with outstanding bioactivity in pharmacology, such as mechanism of antimicrobial, antioxidant, and many more. Principle and concept instruments selected that we use in this experiment is gas chromatography and high-performance liquid chromatography.
First methodology is extraction of flavonoid glycosides in Gingko biloba through HPLC. To obtain their respective extract, 4 extraction methods were used, which is maceration, reflux, shaker, and soaklet. Next is determination of flavonoid glycosides as antimicrobial through this diffusion assay. The antimicrobial activity assays were performed following this diffusion method. Next is minimum inhibitory concentration (MIC). Following the clinical and laboratory standard institute methodology, the MIC of Gingko leaf extract was determined.
Methodology by using gas chromatography consists several of methods, which is phytochemical quantification, collection and extraction of Gingko leaf, procedure, condition for quantification, and antimicrobial analysis. Antimicrobial analysis divide to 3, which is test organism, antimicrobial susceptibility test, and determination of minimum inhibitory concentration or MIC. In extract of flavonoid as antimicrobial, quantitative analysis of phytochemicals were done by using gas chromatography, while this diffusion and proof dilution methods were used to determine the antimicrobial activities.
Results and analysis. Figure 1 showing highest antimicrobial activity synergistic for all the test microorganisms. The highest inhibition zone against B. subtilis was shown by quercetin and isohamnetin, while F. oxysporum was maximally inhibited by quercetin and camphorol. Camphorol showed maximum activity against Putida, while isohamnetin had higher zone of inhibition for M. roseus and S. marsensin. The mixture had high zone.
In this study, gas chromatography linked with the flame ionization detector showed a quantitative of 12 and 13 specific photochemical in the aqueous and ethanol extract. The identification of this specific photochemical was done by comparison of the GC retention time of the standard photochemical, which was saved in the data system library. Flavonoid content was observed to be the highest quantity in both extracts, considering the concentration level of the different components of flavonoid like epicetacin, camphorol, ethocyanin, catechin, and rutin. Catechin have shown the possess antibiotic properties to their role in disrupting a specific stage of the bacteria DNA replication process. It may have contributed immensely to many reported antibacterial effects on the leaf. The photochemical analysis also showed a very little concentration of antinutrient in both extracts. The ethanol extract shows some degree of antibacterial and antifungal activity as observed from their zone of inhibition. Activity was observed on gram-positive bacteria and less activity on gram-negative bacteria. Also, there was an activity on yeast and less activity on molds. The aqueous extract showed no microbial activity on both bacteria and fungi.
As a conclusion, the present study concludes that flavonoid glycoside act as a mechanism of antimicrobial. This study also highlights the importance of various procedures in extraction of flavonoid glycoside.